good afternoon, everyone. And welcome to Transforming the Monolith at 20 million transactions per hour. So this is a talk about culture and how we change culture, and more importantly, how I was subjected to that change of culture. So my name is Nick. My name is Nick Beenham. I work for Comcast, as you can tell by the slides. I'm going to leave my title off there for now, because that's pretty much the story of this talk that I'm going to give today. It's like how I changed from what essentially was an ops guy for 10 years into something a little bit more. Right, so I was part of the ESP transformation, which we ran in 2015. A little bit of background about the enterprise service platform in Comcast. You've heard others talking about it, in the keynotes by Greg and Chris. We do about 250 million transactions per day, so roughly 20 million per hour. We're hosted on about 500 physical servers, and we have a lot of Oracle, Enterprise Java, and WebLogic. So this presents us with some unique challenges. So the problem that faced us was that we had a large legacy code base, and we're going to have to transform this code base, some of which was almost 8 or 9 years old. It turns out I've been at Comcast almost 10 years now, and I actually built ESP v1. Right, so that'll tell you about how far back I go, kind of thing. We had a lot of manual and people-based processes, so everything was a ticket. I want to get something done, get a ticket. I want to change a firewall rule, get a ticket. I want to deploy some code, get a ticket. And it really slowed us down. And one of the things that we wanted to do was we wanted to speed up, and we want to move a lot faster. Let's see here. So physical infrastructure was another one. So that's the 500 servers I was talking about. So physical infrastructure is the enemy of elasticity, as you all know. To give you some idea, it would take us almost 3 months to deploy a server and make it usable, from the moment that we decided to purchase it through to the time that it was actually usable. Our next problem was commingled data. So we had a data model and an access patterns that even Stephen King would probably be horrified at, where multiple owners of the data would all access it for read and write. So some of the things that we had to do was to split up that data and to give it a definite owner, and only that owner could change it. And the last one, and this was probably the hardest one, so we have a large number of services, well over 100, and they're all run by development teams. And part of the remit that was given to us is that we weren't allowed to slow them down either. So we weren't allowed them to say, make lots of changes to your APIs, make lots of changes to the way you call us. And so we had to be transparent to them, not only in the way we developed the servers and services and deployed them, but also in how we enabled them to use the services too. So our approach to this problem. The first part was cultural. We were very much that sort of enterprise SOA shop where everybody had a team and everybody had a job, and nobody really sort of moved beyond that job. So what we wanted to do is we wanted to bring people in, and we wanted to start them thinking about, how do I expand my role? How do I effect change? How do I absorb change? And that's part of the humor here too. The other side was technical. So we knew we had that large, rigid infrastructure, and Cloud Foundry and its adoption really enabled us to change that, to gain the agility, to gain the elasticity at scale. And part of that, along with adopting a complete set of new tools, we allowed us to enable that technical change. So this is how we used to work. Now, many of you probably recognize this from 1990, right? Those firewalls, it might be figurative, but they could have been literal. We had effective blocks between communication by teams, and that was mostly driven by that ticket process that I mentioned. So dev would create the code, they would take the requirement, they would write the code, they would give that code to QA via a ticket. QA would run their tests, and if the test passed, booyah, we'll give it to ops, and ops will deploy it, and they'll deploy it into the environment that it needs to go into. And if it failed there, then it'd be another ticket and back to dev. So we know what happens when you have an outage. We start doing this. And our key metric in an outage is something that Greg alluded to last night, which was mean time between incidents. We were all too busy pointing the fingers at each other, trying to say, well, this is your fault, or it's the database, or it's the network, or it's the server, but it was never the app, and it was never the test. So these are some of the things that we had to change. And it was very fragmented. These teams were all geographically dislocated. They were all in different rooms, or even different buildings in different states, and sometimes even different countries with the offshore teams. So one of the first things we wanted to do was to say, well, let's reorganize the teams. So we did something like this. We built a pod, and we added everybody into the pod. Everybody, right? Get in there, set up your monitors, set up your things. But we were all still just dev, QA, and ops. The only difference now is that we could turn around and shout at each other instead of having to pick up the phone or send an email. So what we wanted to do was actually do this and take away those roles completely. And then this is still very much an ongoing effort. And this is where the sort of change comes in. So as Chris mentioned in his talk, and one of the keynotes is like, I like change. I really do. I really love change. But that comes with a caveat. I like change when I'm talking about it, and it's being applied to other people. Change when it's applied to yourself is never as much fun, as I found out one day. So we were all discussing our work for that day. And we're up at the board, and Mr. Calabrese, sitting in the front row, was there. And we had a need for what we called the ESP router, which is a little Go program that basically unmarshals SOAP requests so we can basically do a strangler pattern onto microservices. So we had this need, and they were like, Nick, you're going to write code? And I'm like, what? See, I'd been good at talking about change. Right? I'd been good about saying, you know what, we need to do this differently, and we need to do that differently. Now if somebody was actually turning around to me and saying, you need to do things differently, and change that I hadn't quite thought about. So I sat down, and after some protestation about, no, I push apps, I build servers, I started to write some code. And I found that I really liked it. I really did enjoy writing code. And I'd been an ops guy. I mean, I spent most of my time writing bash scripts, Perl scripts, looking through logs and things like that, standing up servers. But all of a sudden, I was being asked to write and test code. And that gave me a little bit of an epiphany. Right? I realized that, hey, if I felt like this, then probably every other developer, QA engineer, and ops engineer probably felt the same way. Because it's really easy when you have an SVP in your title or a VP in your title to talk about change and how you apply that to your staff. But I was on the receiving end of that change that time, and it didn't feel as good as I thought it would. So, and one of the things I noticed was that resistance to change, or friction we'll call it, tends to fall into 3 buckets. I don't have to. So I know what I'm doing, I don't have to learn something new, and I don't want, it just doesn't make sense to me. The second one is I don't want to. Right? So we have I don't have to, I don't want to. I don't want to do this because I already have something that does the same. I don't want to change my CI platform because Jenkins is working for me, which is another story. Right? And then the last one is you can't make me. Right? So if you get this in an answer, then you've had it, go back to the drawing board and start again. Because that person's now dug their heels, and then they're going to change. They'll never change. So once I'd sort of realized this, and when I started working with other people and saying, well, I already had answers to these 3 questions, because that's what all the questions and all the resistance to change would fall into one of those 3 buckets. So if you went to the conversation with the answers, it was a much easier conversation to have. And if you had the empathy for that person whose job you were fundamentally changing, again, you were more likely to succeed. So after all this, we spent a long time not pointing fingers and working together, and every time there was an outage, we would get around the table on the phone, we'd open up the bridge, and we'd work through it together as a team. We avoided this. So what happens is that in the old way of doing things is that we would take that piece of code and we would kick it over the wall to QA, and they would kick it over the wall and as soon as it clears your wall, I have no liability, no accountability, no responsibility. And this is what you end up with. You end up with some very unhappy ops engineers at 4 o'clock in the morning who have no idea how to fix the problem. So that was pretty much how we changed the culture, right? And this is where we started moving into what I was going to call standardizing for scale. So when we started the journey, we thought, we'll take quite a radical direction. We're not going to be prescriptive about technology. We're going to let the teams work it out for themselves, which on the surface sounds like a really bad idea. And it could have been a really bad idea. But what happened, and I'll give you an example. So we had to pick a NoSQL solution. And a lot of people went to start looking at Couchbase. And another group of people went to look at MongoDB. But we didn't have Hazelcast. We didn't have Memcached. We didn't have all these different data stores. We tended to sort of coalesce around two solutions. And what was really interesting was that, and James, who's sitting here too, will attest this, is that MongoDB tended to, we have two basically main campuses, one in Westchester in Pennsylvania, and one in Denver, Colorado. So Denver got really excited about Mongo, and Westchester got really excited about Couchbase. And that wasn't through sharing of emails, that was just people talking to each other, discussing solutions over the water cooler and things like that. So we didn't have to make a decision across like 10 different technologies if we wanted to standardize on one. We really just had to have a bake-off between two. So it didn't go as badly as we thought. The second part of it is that we started wanting to raise the bar. Not raise the bar, I keep saying that. Lower the bar to entry, right? So we wanted teams to be able to onboard our technologies as easily as possible. And that meant abstracting things out from them that they didn't have to worry about. So one of the things we took Spring Boot and we extended it. We extended it to include logging, and we extended it to include security. So that was now baked into your platform. So your onboarding application teams could come along, basically pull this down in their Gradle files, and then run with it. And as long as their user was provisioned in the OAuth server, they were good to go. So they didn't have to worry about logging, they didn't have to worry about security, usernames, passwords. It was all handled for them. The next piece we sort of looked at is we wanted to move towards microservices. So these, if you can imagine, we had large legacy SOA services that had evolved over a decade, almost literally a decade. And we were very much a SOA shop. And we still had to look like a SOA shop to our clients and our consumers. We have, I don't know, a couple of hundred consumers, and we couldn't ask them all to move at once, and getting them to move one by one was going to take too long. So a strategic decision was made to say that we're just going to look like SOA, and we're going to talk like SOA, and we're going to act like SOA. But underneath, we're going to be REST, and we're going to be microservices, and we're going to do it in a more innovative way. So what we came up with was our little ESP router. So this thing, it's maybe half a dozen files, 500 lines of code, if that. And it unmarshals the requests, and it forwards it on to the methods that are declared in the SOAP bodies. So as far as our consumers are concerned, it just looks like the old way of doing things. Now, if they want anything new, then they have to call REST, right? This is just to get them onto the platform and using it and consuming it without having any impact with them, without having to go to these teams and add a whole ton of stories to the backlog saying that you need to update and you need to use this and we need to change your schemas and things like that. And then the second piece was this de-mingling of data, and this is still very much a work in progress as we move off. We used to have lots of Oracle RAC, and it's very painful. And we did manage to do site-to-site replication with Golden Gate, as long as the network doesn't have a fit and it bends. But we really needed to start fixing those access patterns that I talked about at the start of the talk, where we had multiple people writing to the same sort of set of data. We had to identify owners and then abstract them away. And this is just like, almost like the same pattern, but in reverse. We started creating access or CRUD services just to front that data so we could then keep it off. Right, so the next sort of piece is how we changed our sort of technology stack. And as you can see, Cloud Foundry did give us a unique set of capabilities that we never had with WebLogic. We could change configurations really quickly. We could deploy new. We could scale really quickly. And it was just a much better experience. And even deploying. We used to do these massive monolithic blue-green deployments that would take, how long did it take? About a week to deploy the entire stack? A long time. So Cloud Foundry, we deploy in minutes, as long as somebody doesn't set an overly ambitious scale over time. And we can deploy as often as we want. Sometimes we'll deploy multiple times in an hour. And it's given us a great deal of velocity that we've never had before. Our data, like I said, is moving from Oracle into Couchbase. So NoSQL obviously offers a lot of positive solutions, especially when you're looking at multi-site over rack. And our routing is, well, we used to do what's called, I'm going to call IP-based routing, where we would take the source IPs of the consumers, and we'd basically route them through F5s, the F5 load balancers. So with Cloud Foundry, because we don't have IPs anymore, we had to sort of change that a little bit. So now we set what we call a source system ID in the headers. The F5 reads the headers and then routes to the different foundations based on those consumers. Our delivery stack has also changed. So we started off in Jenkins, and I was going to tell you about a painful story. We had a 4-day outage. Jenkins went down and then wouldn't come back up at all. So after a couple of days, we made a sort of decision. We're going to move to GoCD. And for the most part, that's been a much better experience. I mean, GoCD does come with its own set of issues, but overall, it's been a lot better. It's allowed us to do much better in the way of pipelining, and the continuous delivery models are much better. Our builds, we've moved from Maven into Gradle. And again, that's allowed us to create a lot of Gradle plugins where we can abstract a lot of the common tasks out and then run those as they're required within the pipeline templates. And it leads more back into that whole standardizing for scale. Our deployments were very script-based. So we would have thousands of lines of bash just deploying out to various WebLogic clusters now. That is, for the most part, moved into Cloud Foundry plugins now that are called from within the pipeline, and I'm going to talk about them in a second. In fact, I'm going to talk about them now. So Cloud Foundry comes with an autopilot, which is sort of a zero downtime plugin, except it's not quite. So the way it works is it just waits for that first instance to come up, and it says, right, I'm good, we're done, old version, off you go, right? Which is great. Unless you're taking tens of thousands of transactions a second, one instance isn't going to cut it. And then what it turned out to look like an 8-minute outage for us every time we did a deployment, because we couldn't spin up the instances fast enough to satisfy the demand. So we would get into this crash cycle where the instances would become overloaded and they would go down and just start recycling. So we wrote the ZDD CLI plugin. And what does it do? It builds on some previous work by a chap from Pivotal called Joshua Kruk, who wrote a scale-over plugin, which basically what it does is it'll take two versions of an application, and it'll spin one instance up of the new version and take one instance down of the old version. And it just does that, so then it takes 2, 2, 3, 3. And over this period of time, which you can set as a parameter, you can roll over from one version to a new version. And that's given us a lot more flexibility in how we do our deployments. And it takes the parameters based on time. So if I have a lot of instances, I can set a longer parameter to roll over. And if it's just a few instances, I can then set a much shorter time. One of the other things we started to do was canary deployments. So the idea is that we wanted to be able to, much like the Bosch canaries, we wanted to deploy one, test it, and then if it passed our sort of production smoke tests, we would promote it. So we wrote into the plugin a way to generate a custom route, which would then be passed back into the CI to run the tests against. And the tests would then be run against that custom endpoint instead of the production endpoint. And then if those were passed, it would then go on to do the same sort of scale over again, but from using that canary onto the full live version. And that's, again, given us a lot more consistency with those deployments. And that it's not an all or nothing thing. And if it fails, then we just don't promote, and we just leave it where it is, and we just delete it. This one's pending open source, so I hope to have the legal pieces cleared up within a couple of weeks, and we can get that one up for you. A couple of other pieces that I've written recently. One is a recycle plugin. So we had a need where we would change property files, and some of us we're using, I forget which is the one that uses a singleton, Jersey. So it needs a restart. It's not like the Spring controller where you can just recycle the instances. So this one will just basically drop one instance, bring it back up, drop one instance, bring it back up, and allow you to refresh properties without having to do a total restart on the application. The scalar service was something that I wrote to basically allow us external APIs, like our monitoring platforms, to be able to say, if I reach things like a CPU threshold, I can start scaling my application. I can increase my instance count. If I don't have access to the foundation, I can hit an endpoint locally on it. So what do we have on the horizon? So we do have a lot of external processes that tend to impact our day-to-day lives. Change management is a good example of this, where we have to integrate with an external process. We still have a very manual process with a lot of humans involved. So that really does lead to our cycle time increases. We can't get down as far as we would like to with that. We want to onboard more teams and services to Cloud Foundry. We did about 5 or 6 last year, and we're looking to roll over everyone else this year. By the end of the year, Chris? Right, good, still the same. Exploring the use of Concourse. Some of my colleagues like this more than others. I'm quite a fan of Concourse. I like the way it does things. I like the way it does things the same way every time. That every time you run a job on Jenkins, or even GoCD in the agents, that you're changing the configuration of that agent slightly. Whether you're increasing disk utilization, leaving files behind. Concourse running in Docker containers doesn't suffer from that at all. And then this is one of the exciting ones that I've been working on in the last 3 or 4 months. I got bored in a couple of meetings, and I was listening to people saying, "What's the status of this application?" And to me, it seemed ridiculous that someone was actually asking for what the state of the application was. And I said, well, why can't we just ask? And we were all chatting away in Slack, and I thought, why can't we just ask Slack? So we wrote a bot called Marvin, who's slightly paranoid and depressed. No, his name is Marvin. That's not a joke. And we started integrating him with our systems. So he integrates with our monitoring system. So you can set up subscriptions on your applications, and he will notify you when something bad happens. He's also tied into Ansible, our Ansible Tower implementation, so we can actually start provisioning infrastructure directly from Slack, which is kind of cool. And some other systems like the CF Scalar service, like so. So you can actually have Marvin scale your applications directly from your mobile, your phone, and your Slack client on that. So this is a quote by Terry Pratchett. And I spent a lot of last year and a half looking at various systems. And one of the things that always struck me is like people like systems that do a lot of stuff, but then they don't use maybe 80% of that functionality. And they come with big manuals. And you spend a lot of time reading the manual only to find out the system doesn't maybe do exactly what you wanted. And I've always been a Terry Pratchett fan ever since I was a kid. And I remember this quote, always be wary of anything helpful item that weighs less than its operating manual. So if you only need a small tool to do a small job, then pick a small tool. Be wary of the Swiss Army knife. I look at Jenkins as the Swiss Army knife of a lot of things. It does 150 things, and none of them especially well. Every time you change a plugin, you cross your fingers when you hit save, and hope it doesn't bring down everything else. And I guess the other thing we looked at was always have something in your back pocket. So I've been working with a standards group now recently at Comcast. And what we've been looking to do is say, well, what's the next thing, right? We know something's going to run out on us at some point, at any point. We want to be in a position where we already have the next best thing ready to go. And you have the means to onboard people onto that too. So Concourse is maybe an example of that, where we already have GoCD. We know it has some pain points. What's the next thing? Or moving from Java 8 to Java 9, the new versions of Spring coming in. Be ready for them so we can take advantage of them as soon as possible. And I guess it brings me back to my sort of first slide. My name is Nick Beenham, but I don't have like an operations title anymore. And I remember seeing this one across the internet. So I just call myself a stuff doer now, because I tend to do a bit of everything. And I didn't really know a name for that. And I was reading an article a few weeks back, and I came across the term full stack engineer. To be honest, I couldn't believe I hadn't come across it before. So I consider myself to be a full stack engineer. And currently Comcast is looking for a lot more. So if you're interested, you can hit up comcast.com.careers, and we'd love to talk to you. And that's pretty much me for today. So I'll take any questions that you guys have. Yes?
I have 2 questions for you.
Mm-hmm.
You guys did all the eliminate the ticket system so you can push to production with no tickets. Second question would be, did you eliminate the silos so you have a dedicated DBA network person on your team?
Right. So the first question was, could we eliminate the tickets? And the answer is no, not yet. We're still working on that. And one of the things I started looking at was like, how do I remove the dependencies on other systems, right? So when you have like a highly coupled system, that's really difficult. As we started to move to microservices, we're much more decoupled. So the number of touch points that we might need will start to decrease, and hopefully we can start to get away from some of those tickets. Now, the siloed piece is another one. So I was listening to a talk by one of our VPs a couple of weeks ago, a chap called Jason Lenhart, and he had this idea that if you want on the team, you write code. That's it, I don't care. Even the manager of the team writes code. The ops guy writes code. And that's the only way you get on that team. So I think that's maybe the extreme end of it, but there's no reason that people can't sort of learn from each other. And I think once you start taking the labels off people, like the DBA should be able to pair with another member of the team, and you're going to get some sort of cross-pollination of knowledge of that. It's like the idea of having a knowledge transfer because somebody's leaving seems sort of ridiculous when you think about it. If you're all pairing, there should be no knowledge transfer because everybody has the knowledge in the team.
Do you have separation of duties? Do you update critical tables in production or critical tables in production?
No. Yeah. So the schemas get pushed through the pipeline. They're automated. So a lot of the database deployment's automated as well. So if you make a change to like the QA tables, that'll get propagated through. So in theory, yes, you are making your same changes, which is a bit of a Sarbox issue as well, I would imagine. And that's a question I haven't really found a good answer to either yet, is how do you stay out of that sort of regulatory piece, Yeah, no, so I would say it's almost impossible. But even us, Comcast, we take credit card payments. So we're impacted with that too. We still have to be PCI compliant on some of our services. Hi, yep.
When you go into the data storage side of things, you guys say you're discussing Couchbase and other solutions like that.
Mm-hmm.
How is your sort of dealing with the migration of the data? So you said you created this sort of data access component in between the data.
Right.
Did you do some form of live migration to take that chunk of data off of that?
Right, yeah, so we had to do almost like an ETL piece on that. And then I think we did most of it was done as a multi-write. So we did like a dual write to both systems, so to keep them in sync.
Were you doing that at data access component?
Right, yeah, so that would take care of that piece, yeah.
With move to Cloud Foundry,
yes.
for sort of your app area, were you still using a separate cloud setup for your data storage? How was that set up?
Right, so we ended up putting a lot of the data pieces onto just regular VMware. We have another sort of like a sort of on-demand like VMware cloud that we have. We did take this sort of decision at one point where we didn't want to try and boil the ocean, and then to split the data question off from the application question, and like you say, just abstract that out with a service, and then we could solve that problem separately. It's in the process. We did solve it accidentally for about 3 months. And then there was an unknown configuration change. Well, not unknown, it was known but unrealized that we were actually running out of one of them. There was no issues, so it was just a surprise. A pleasant surprise you could think of looking back on it. But
usual migration is always the app migration, but not the data.
Right, yeah, no, the application is always the easy one to solve. The data is always going to be the hard one, especially when it becomes transactional data and you have to deal with like geography in between them, and it brings in things like conflict resolution and stuff. Yep. Anyone else have questions? All right, guys. Well, if no one else wants to talk, I'll be around for a little while anyway, and I'm quite happy to answer questions as well. Great, thank you very much.